the right thing, which I think is the slideshow itself. Now let's see if that, yeah, it looks slideshow-ish. What do you think, Ariel?
I say let's roll with it.
You think? You just don't even care? So here's the thing about, so for everybody here that it's, and for everybody that's on the live stream, really, this is one of those moments where PowerPoint is delivering for everybody. Right? So there are no notes for this deck, which means you're going to see the same thing I see, which is great, no problem. So I don't know if you're looking at the whole preview thing, you're going to see that there's bananas in the next slide, which is in keeping with the theme. So here we go. The whole I don't know this cheese of which you speak is a reference to Hitchhiker's Guide to the Galaxy. That'll be very much an Anglo-American sort of cultural reference. Forgive me if it doesn't pass, but if you look that phrase up on the internet, you're going to find all kinds of cultural information that will enrich your life, I'm sure. My name is Ralph Squillace, so Ariel will be buying me a beer later. That's sort of Italian, but I was born and raised in Seattle. I spent half my life in San Francisco. I'm a New York transplant, about 3 years now, the COVID period. So I can't tell you how happy I am to see people in person. I will hug each and every one of you. So you need to say no. And that's totally fine. We're going to talk about something that is a little weird. So for the last 12 years in particular, 12, whatever, depending on when you entered the ecosystem, the container epic, as I tend to call it, is like, this is what we have lived and breathed in cloud native. And Kubernetes sort of emerged even after that epic, out of the orchestration wars. And I use that phrase lightly because this is how engineering works it out in real time with developers like you that do the work of choosing a platform, for example, and then contributing to one, which is an amazing thing that we all get to do together. So the odd thing is to talk about some other technology and Kubernetes that is not containers. And I'm hopefully here, the main point I want to talk to you about is why we might do them. So let's talk about the agenda. I can talk, I'll talk about the agenda if I can flip the slide. There we go. So what I didn't mention is who I am, in case you have not heard of me, which is probably better for you. I am a principal PM on the Azure Core Upstream team, and that's the team at Azure that deals with upstream technologies in cloud native space. And so a lot of the work we do is with containers. I used to be the Helm PM for a long time. Bridget Cronov is the Helm PM now on our side. And then we did Porter and cloud native application bundles. I was the PM, still am sort of, for the VS Code Kubernetes extension, which is in the CNCF, believe it or not. It just works with any cluster. It has nothing to do with anything specific. So that's something you should look at. So a lot of that experience is in this area. My team also does Moby builds. They do all the upstream builds for things like Kubernetes, for things like Azure Kubernetes Service, stuff like that. So that's the area, but we're on the open source side. We handle all those technologies. And so one of the things we've been talking about is how do we do more with Kubernetes, right? And so the high order bits of this talk are going to be try and talk about why anyone even cares about this Kubernetes with WebAssembly thing. So that's one bit. The other thing I'm going to talk about is why Kubernetes really is the JavaScript of control planes. I'm hoping to irritate you a little bit here, because if you're irritated, we're going to have a lot more fun. The third bit is I want to talk about why WebAssembly, in this case abbreviated to WASM, is for future clouds. It's not necessarily what you're going to be thinking of for your workloads in hyperscale right now. Okay, so this is very much a future looking thing. And you got to think about, like, where can you apply this ability? Because WebAssembly is not the be all and end all of any technology. And in fact, as engineers, we know that almost none of them are. So you got to think about the metaphor is peanut butter and banana are really great when you need protein. Your engineers, your operators, your service customers, and so forth. You need protein, and you will choose peanut butter and banana together when you know that's the time, and not in another situation. So we'll talk about that. It's very important to understand. And finally, we'll have a bunch of demos, including a really great demo that we just landed recently. I'm going to torture the person who put it together. They are here tonight. It's going to be a wonderful bit of fun for me. I hope for you, but not for them. All right. So let's start. Why are we doing this? Why do we even care about WebAssembly and Kubernetes? And the answer, like the way I want to talk about it is, like, we don't feel any pain from Kubernetes, right? I'm going to look at you, whom I don't know yet, but I will afterwards because I'll get you up here for tolerating me. Like, do you feel no pain in Kubernetes?
No.
Yeah, big hesitation. Right? Okay, so obviously this is provocative. Yeah, there's some pain now because we've survived 6-7 years of working out the problems with Kubernetes in production. And mostly those pains are revolved around like things like YAML, for example. Who likes to complain about YAML? Yeah, you're right there.
I love YAML.
You are a strange human and need to go drink right over there. Okay, there you go. But we will talk afterward. Yeah. So I'm a veteran of the soap wars of WS, so I'm an XML veteran. I think I have a discussion for you. But some of the other areas that we have problems with, right, are the infrastructure work that we've worked on over the last few years to sort of make Kubernetes more offerable, more friendly to developers and so forth. Things like service messes, not service meshes, service messes, secrets and hardening. We got to try and figure out pod identity. Oh, excuse me, it's not pod identity, it's something else now. Hardening in general, various distros, services, the rev cycle, and so on. But after all that, not inconsiderable stuff, people are in fact building great things with Kubernetes everywhere. And it's not just my company, which is some big company can throw tons of money. Like, we're talking about small ISVs. We're talking about individual developers can use this anywhere. And they can use some of the distributions, not just ours, but everybody else's, right? This is huge value and huge abilities that people have now that they did not have before. And that's important. Why are they building great things? Because Kubernetes is the JavaScript of control planes, you people, right? Like, you don't have to like it. You didn't necessarily have to design it, right? But you know and use it. So like the ecosystem of tooling and services is super large now, right? You can take your skills all over. So I tortured you a little earlier, right? Like, I'm going to focus on you again to torture you again. Like, you can take what you know to Kubernetes. You can jump from one company to another. That's great for you, but it's also great for the companies because they can sit there and pull from this pool of talent. That means there are more opportunities, not just for those companies, but for new companies, right? This is fantastic. And finally, you can take your apps all over, right? So it's not just Manifest, it's Helm, it's Acorn, it's whatever might be done, right? With Kubernetes, the API is the same. It all comes down to making it work with Kubernetes. And that's fantastic. I'm going to pause for Scott. Okay, 1, 2, 3, you're done. Scott's gonna be the person who throws things out.
I got the best photo.
Yeah, there you go. So what is the problem we're trying? What? Uh-oh, question. Go ahead.
Third question. This question for your last slide. So based on your last slide. So
Last slide.
Douglas Crawford. Who's our Douglas Crawford?
Douglas.
Let's see if it's the JavaScript.
Oh, good God. Oh, you're trying to provoke me in the middle of my rant. No, this is a JavaScript rant. You and I can talk about who the personalities are later. Now, so you're really quickly, right? You can actually hold on to that. I think the battery will probably hold. Really quickly, by the way, anybody can interrupt at any time. If I want to make sure I get through, I'll get through and then come back to you. Don't worry about that. The interesting thing is that the JavaScript and WebAssembly, if you know something about JavaScript and WebAssembly and where WebAssembly came from, and we're going to talk about that in a minute, right? There's a whole bunch of conversations that are from that ecosystem, in that ecosystem. And I understand them, but I don't come from that ecosystem. And so I don't really hold any opinion about the sort of metaphorical mappings that you might be asking about there. So you're going to have to forgive me I'm going to give you that answer now so I can keep going, but I'll be glad to talk later.
That's a lot of hard questions about
things that are well. Yeah, exactly. Okay. So what is the problem, right? What is the pain we're trying to address with this? And in fact, there is no problem. Okay. But that's only if you take the prism of your experience for the computing world that we have built as a collective community and as an industry, both, right? Because there's tons of individual work in this world that contributed to this the abilities we have now in what we call sort of cloud native, right? But also as an industry, we're sitting there thinking, okay, we moved from VMs to containers, now we've got it. Okay, I'm sorry, but the work and the world doesn't stay the same. So what we're really talking about is not the status quo, we're really talking about the future cloud. And so this conversation is about how Kubernetes can engage the future cloud, not just the cloud that we currently have, which actually works pretty well now, even if it's JavaScript, right? The future cloud is already here. I apologize to William Gibson if he ever receives any of this on Twitter. But it's unevenly distributed, as things are when they arrive. The public cloud epic is stabilizing, and this is kind of the message I want to talk about in terms of why we do this. So the message, the cloud epic that is stabilizing, right, means that we're still seeing, and I can speak to Azure, but I'm thinking about like a Gartner thing, an industry thing, right? Amazon, Azure, Google, DigitalOcean, Alibaba, all of the clouds in the world, OVH, you know, everywhere that you can run Kubernetes, right? That accelerating curve is the acceleration rate is beginning to plateau. It's still massive. There's still a lot of growth there. There's a lot of work to be done, but that we can start to see the bend of industry plateauing, which means that the world is starting to think about hyperscale containers and Kubernetes as being a thing they know. And so there are fewer and fewer people, and as we go forward, fewer and fewer people will gain economies of savings as they migrate to the cloud, because probably most of those workloads are already there. And that won't happen right away, right? But we're looking forward. So the question is interesting. I don't know if anybody noticed, but chip production is accelerating even during the epidemic. This year's chip production vastly larger than last year's chip production, and all we do is complain about where's my RPI, right? Okay, so what's actually going on with those chips? Those chips are going to a new area. They're not going to hyperscale cloud. They're going to what I call circumference or periphery compute. Now, the market calls this edge. And that means it's not riding on a VM somewhere in a Kubernetes cluster in Google or Amazon or Microsoft or DigitalOcean or Yandex or OVH or Alibaba or the cloud here. Somebody give me another cloud. Oracle. Thank you. Actually, that's kind of funny, but at the same time, thank you. That actually is a good example, right? Like there are clouds everywhere, right? The industry calls that edge. So here's the future in one slide. And this is the area I want you to think about in terms of Kubernetes. Data centers were for industry, basically. Nobody built a data center so that Ariel here could like have a happy experience. Ariel doesn't generate revenue for them, right? Like, this is for industry to generate revenue. And don't get me wrong, I'd do anything to make Ariel happier. Okay, no, that's not true, right? Like I do a lot, but not that last bit. The point here is that Ariel as a developer doesn't move the market, right? It's industry that moves the market, but they were interested in data centers. We're coming from data centers. They wanted data center experience, but they wanted cloud native. And that's what the cloud did. That's what Amazon did, making the market in VMs, right? And they kicked off an incredible explosion of productivity. And along with Kubernetes and containers, we've got a sweet spot there, all right? So DCs, data centers, and Kubernetes gave everyone cloud native. This idea that you could go now, break it and replace it instantly, not worry about which particular POSIX kernel it was. It doesn't matter, just go, right? And that turns out to be incredibly useful for a number of reasons. But circumference of compute is the area off hyperscale that's beginning to understand that this is not the only major compute market, right? CDN compute. So we're talking about Cloudflare and Fastly and Netlify and Vercel. Vercel, I'm going to take that one over there. I've never actually pronounced it out loud. Who said that?
Jimmy.
Jimmy? Okay, so I'm not going to torture Jimmy right now. It'll be later. So the critical and also the big three, because you'd be crazy to imagine, and I don't have any specific knowledge, but like you don't have to be anybody in the industry and software to understand that if Cloudflare is doing it, Fastly is doing it, Netlify is doing it, Vercel is doing it, others are doing it, right? The big three are going to sort of sit there and put something out in the future. And I guarantee you it's happening right now. And I don't even know, right? Fantastic. But, huh?
You probably do know.
You be quiet.
I mean, you know, for sure.
I might have knowledge about Azure. All other compute, this other compute, the CDN version, because CDNs actually use WebAssembly as their process model rather than containers. Okay, you can run containers on Edge on CDN compute right now. It's just not the experience that these leading vendors provide for you, and they use WebAssembly. All right, so all other compute that is not hyperscale doesn't have the cloud native experience yet. All hail, I say, are cloud native other compute overlords. So what does it look like? This is the market that's coming. So all of these figures I'm going to give you here today are taken straight from the internet. These are not Azure, Microsoft special research figures. You can go ahead. This is from Fortune, like within a month, right? An article on it. The others are in the slide deck. I don't know if you can see the notes, but if you can see the notes, you can see the links that I took these from. Okay. The numbers that Azure has, for example, that they provide to me are more specific, which means they're a more specific swag, right? These are guesses. But just to get you an idea, industrial automation as an environment is going to grow 10% per year, 400 billion by 2029. Would anybody like to provide some of that service, right? Especially with open source stuff they can do even as a small company, as a developer? Yes. Space onboard computing grows 12%. Now, this is actually a radical underestimate. Right now, in 5 years, there will be data centers orbiting this planet, okay? In 5 years, there will be data centers. Now, it'll be very expensive data centers, okay? But they will be the same data centers that we built on this planet. They will be another form of edge. They will be much smaller and constrained. They can't scale out as much, okay? So you got to have some other way of increasing compute. They will be different SKUs, different hardware. They won't be standardized like, you know, designing your own custom ARM chip and then spreading that same ARM chip across the entire world in 170 different PCs, which is what the kind of thing that the hyperscalers do, right? This is almost certainly a radical underestimate, but that is what the market is saying right now. And IoT is even more. So if you collect everything else, right, random guesses are in excess of $1 trillion over the next 5 to 10 years, depending on which survey analytics company you might be talking to. This is the compute of the future, and we keep thinking of IoT as if it's special compute. Everything with IoT is thinking, oh, well, I'm going to give you a container. No, you're not, my friend. You may give them one and bundle everything into it, right? But in those environments, you're going to give them native. And so we have native SDKs, native services, native everything, right? This is not immutable. This is not the cloud native workspace. So this is a huge opportunity, but in this opportunity, containers aren't necessarily the perfect thing. We'll talk about that. And then finally, more data is going to be created in the edge in the next 3 years than the last 30 years combined. Now, every year we hear this statistic. So it's a common statistic. This is this year's version. Feel free. Okay, but in 3 years, actually in 2 years, because we're almost 2023, this is going to be 80 zettabytes produced on the edge. There is no way anybody is going to pay to ship that data to hyperscale, process it, and then export and pay egress costs to get that data back somewhere off of hyperscale. That's not going to happen. So where's the compute going to go? the metaphor of MapReduce becomes clear. You're going to push the compute out to the edge. But if it's native or containers, it's going to have difficulty in these environments to process the data right there. Make sense? Okay, so this is very interesting, right? Kubernetes can win here. And by win, I mean you and everybody who has Kubernetes skills or wants to have Kubernetes skills can actually work here. And the reason is containers are the real issue here, getting out to what I call constrained heterogeneous compute environments. Containers are the issue, not Kubernetes. Now, Kubernetes is not a real-time system, right? So don't get all excited about that, but, right, it can actually run really, really, really fast, which is all you need for, say, 80% of your compute there, right? You need data process. You don't always need literally atomic milliseconds of precision. But even with real time, you're going to need some compute cloud native abstraction for the process, right?
You're gonna need that in space.
You're going to need it in space for sure. But it's not just space, right? It's like automobiles. It's like planes. It's like trains going across the country. It's like boats going across the ocean. It's going to be your walking cane going to Walmart to make sure you buy your thing. I mean, like all of these things are going to be possible, and some of them we don't want to admit, but some of them we do, right? The world is, this world that we're talking about for Kubernetes is smaller, slower, and more heterogeneous, and specifically with respect to OS architecture, but also with language and with multiple runtimes and so forth. All right. Containers are likely not the core solution. How do we bring Kubernetes productivity and our skills to affect this market, this new cloud, this new compute, right, that straddles the world, which is, I admit, still scary, right? The answer is it's not containers. However, this is not a rant against containers. They are the 90% workload of scale-out computing because they work fantastically. So nobody here should be thinking, oh God, I've got to rethink containers. That's dumb. They're amazing, right? Anything that is a long-running process that sits there and does good work and you already have it running, and where you could X-copy it in and dork around and get it running in hyperscale that somebody else pays for, that is it. That is the perfect world for containers. And we built incredible agility out of that for everybody, right? So that's absolutely true. Instead, what we're going to have modular and containers together, right? So we need the features that containers lack. That's why WebAssembly is interesting. And I want to stop here for a brief moment and say, I am not here because WebAssembly is perfect. It is not. There are critical flaws, and I'm going to talk about some of them. Reasons you would not choose to run WebAssembly. And one of them is, I've got code I want to X-copy. I need a POSIX kernel. WebAssembly isn't a POSIX kernel. You got to bring your POSIX kernel if you want to run it that way. And some people do, right? Anybody heard about webvm.io? If you want to have fun, go https://webvm.io. They do great stuff. I love it. Great stuff. But the point here is that no one cares about WebAssembly. They care about the feature of using Kubernetes to do work, right? So what are those features? Super fast cold starts. Super fast. I can start an optimized WebAssembly function from a network request in about, let's say, half a microsecond. We're talking about 500 to 800 nanoseconds. And I have seen people start in 2 to 3 nanoseconds, right? But that's like obscene optimization without anything in the way in any way, shape, or form, right? And of course, this depends on your architecture, your RAM, your, the whole hardware setup you have. But we can reliably hit nanosecond starts and entrances into a WebAssembly function. That's incredibly fast. This blows away containers. And I'm talking about an empty container, like distro list that returns a string, right? Just the container ecosystem is not anywhere near that fast, but it's fantastic because compared to VHDs, it's amazing. So be an engineer, think about the feature you're dialing into, not the technology. Another feature, by default secure. So in WebAssembly, the sandbox does not permit any exports or imports unless the host says, I give you permission for this ability. That is exactly the feature we have been wanting in containers for God knows how long. And we do seccomp and app armor for that kind of stuff, in addition to other kinds of controls, just to prevent that. So that's a feature, not a technology. It's very, very small, and I'm going to show you a little bit about this. Egress, storage, working set dramatically reduced, and portability in 4 dimensions. OS, architecture, language of runtime, and location. All of these have limits. So my phrase is really, WebAssembly is like write once, runs 75% of the places. There's an obvious joke there, but I think that's actually a fair characterization. 75% of the market off hyperscale is massive, massive. All right, so let's talk about a portability example. And I want to give you an idea. Okay, so this is a demo that Radu Matai, that used to be a developer on my team, is now a developer on Fermion. I'm going to show some of Fermion stuff here today. Did last year. This was last year. Now, the real question is, I don't know if Radu has, if the video will be projected here, or the audio, but I'm going to show you and talk you through it. Right? Let's see if, well, I thought
Bigger.
what's that?
Did you make it bigger?
Oh, it's, yeah, I can run it native. Let me stop sharing. And we'll open this up. Oh, great. It's over there. It's still over there. Okay, fine. Now I got to go over there and grab it. And I can't quite grab it. Oh, I think I did. No, I didn't. Okay, technology failure. Here's what I'm going to do. File Explorer. I give another, did I get another instance? So here's the problem. I'm projecting.
Their way to mirror.
Yeah, I'm going to mirror.
Share.
Yep. Okay. Duplicate, because we have to name something differently than mirror, because that's the way the world is. Hey, that was a good laugh right there. It's actually true. So this is a WASI NN. Oh, I got to share my screen again. Okay, so I'm going to do that 1 second, and then I go back to Zoom. Where's the Zoom thing? And I got to share my screen, share screen, and then I'm doing the dim. No, that is, yeah, I think that's right. I'm going to share the screen. I'm just going to let you see everything. I'm rolling with the punches here. All right. Okay, there we go. So this is something we did last year. Now, this is a WebAssembly module that we're going to run on 2 different architectures, AMD and ARM. We're also going to run it on 2 different operating systems, and we're going to run it in a matrix with GPUs and CPUs. But the model for inferencing, so this is an Onyx model, it's actually, I think it's a PyTorch. No, it's a MobileNet V2 model, right? And using Onyx, we can actually use any model, right? And we've compiled that to WebAssembly. And so what we can do here, and I'm not really clear whether I'm going to hear Radu's dulcet tones here. No, it doesn't seem like I'm going to. But basically, we're looking at compiling this Rust WASM. This is about a 2 megabyte module. And we're going to go ahead and dance all around. So he's going to go ahead and compile this. He's talking about it. Let's get over the period where he's talking about it. Yep. Okay. So we're going to dance over here. And so he's going to go ahead and run this. And this is like on Mac. You can see that it's on Mac, right? And he's done some inferencing here. And you can see the inferencing is like, we think it's a mushroom kind of thing. And it's too, you can't because it's too small. Jeez. Okay. Well, I'm going to run it. And then like when you get home, you got to go, right? So what I'm going to describe here is that we're jumped into an SSH session with a Raspberry Pi. We're going to SCP the module over there. And if you see right here, which is too small, it's 2.7 megs, right? It's the same exact workload. We're going to run the same exact command, and then on the Pi. Now notice we didn't have to build a different architecture. We didn't have to pump over a large container, right? So this demonstrates the whole portability aspect of WebAssembly. And so here we're going to go to WSL, I believe, and we're going to run actually with a GPU instead, or I think that, yeah. So super, super fast compared to the Raspberry Pi. But we did not modify the code in any way, shape, or form, right? So I'm going to go back to the presentation. I'm actually going to be, you're going to actually be able to, whoops, screen share is paused. Okay, every time I touch this, it gets mad at me. So there we go. We're going to go back to the slideshow. And are we seeing the slideshow again? Okay. So from here, I want to talk about WebAssembly itself, right? Just so you know what we're doing. Stack-based abstract VM specification, and this has been used. What's that?
Hide the Zoom stuff.
Hide the Zoom stuff because you don't want to see my mirror all the time. Would you?
Hide the Zoom stuff. I have to say, I
Like, okay, hold on,
Zoom,
hold on.
reason.
Let's yeah. Zoom is helping us out. There ain't no dot O down here.
Yeah.
Hide video panel. Nice. Zoom masters.
There should be another hide.
Hide floating meeting controls. Yay. Okay. You get like cash on the barrelhead. That really was the biggest surprise. And I'm very disappointed, by the way. This is you gotta, liven up. No, I'm just kidding. This is a virtual VM specification, essentially available in all browsers since at least 2018, earlier in some cases. And so you might know it because it grew out of the desire to sort of pre-compile complex JavaScript to bytecode before sending it to the browser. The idea being that you could actually compile C code, legacy code, and so forth, and then run it in the browser without having to interpret it, right? And that worked really, really well. So things like Google Earth and Lightroom, right, have done this. And so if you know about WebAssembly, you might think about it that way. The critical thing here is the host completely controls the WebAssembly. Obviously, in a browser, you would imagine that. You can't have somebody breaking out of the sandbox and then controlling the machine from the browser. All code is deemed untrusted. And this is one of the critical features for not just hyperscale or IoT workloads, but basically computing as we now know it, right? Because our comparison is containers have a full shot at the kernel. That's our comparison, right? So there are problems with it. There's no threading. There's no GC, memory management. Those things are on the way, but they're not going to arrive anytime soon. And so the sweet spot here, right, is in a different place. Okay, I got to click this in order to get focused. Now, the two things that I'm mostly interested in, and I think most people should be, is not just WASM. And the reason is because exports and imports can be custom defined there, and then the module is not portable. Because other host models, other environments will not understand the exports and imports. And so you have to come up with a specification that allows this. And there are two that are critical. One is, in my opinion, so this is an opinion here. One is the WASM system interface, or WASI, which is essentially an abstract syscall list. You might call it a spec, but it's really a list of APIs for that multiple languages can compile to, can think of as a POSIX, standard lib, right? But it's not specific to any implementation. So it can run in any browser, it can run in any runtime, any operating system, so forth. The critical thing here is that you don't have to implement all the features. So if you want to run web services, for example, you don't have to give your kernel in WebAssembly file system access. Like, you just don't implement that syscall. And it's very different, right? In edge scenarios where stuff, I almost said a different word than stuff, where stuff is not necessarily controlled as tightly, the runtime and the VM engine can now enforce the standard live level calls and only expose what that environment permits. And that's incredibly useful, right? The second part is the WASM component model, which I think of as the WASI component model because I want them both at the same time. But you can have WASM modules that are not WASI, but do implement the component model, right? So you can mix and match here. But I like both of them because you can define a capability with an interface, and you can also define what the host must implement and no more. So you can take and implement an interface. I'm going to show this, right? And the host, if it doesn't implement the complementary interface, the module won't run. And it's not just an aspect of WASI. You could implement the whole kernel in the module as WASI, right? But it still won't run because the interface with the host doesn't match. That's fantastic as well. Think about the environments that we deal with in containers. Those are kind of opaque. You really have to have out-of-band control of that. Okay, so the sweet spot for this. We're engineers, we're operators. You should think of fast processing and resolution. Fat, hefty hosts, big web services and stuff are not the sweet spot for this. So you gonna have a question, or are you just having a great yawn? Because if you're having a great yawn, that's totally fine. Especially because I've also had a glass of wine. Thanks to the host here. So the other one is constrained heterogeneous compute. In these environments off hyperscale, pure speed might not be what you care about, but rather the ability to be small, contained, secure, and cloud native in developer, in operations, and so forth. And COGS reduction. So in core hyperscale, right, the only thing that's really interesting right now, containers work great. Keep using them. So the only thing you might be interested in is a reduction in COGS. How much of a reduction?
Is COGS.
COGS, oh, cost of goods sold. And typically what that means is if you're running a service, right, and my company runs services, it's how much you have to pay to keep the stuff running. And that directly affects how much you have to charge customers. So if you can reduce COGS by half, you can drop the customer rate by half, because that's what all big companies do. It's exactly equal to the COG improvement. All right, thank God there was some happy,
A
huh?
lot of companies get different OpEx to COGS. You know, I feel like a lot of companies still model this on the OpEx side and don't have.
Yeah, in fact, it doesn't really matter, but you've got to pay for OpEx.
Could you repeat the question?
So as a lot of people, so in fact, let me channel the question. The question is, I feel like a lot of people still model this as OpEx, which is operating expenditure, right? Or operating expenses, as opposed to cost of goods sold, right? There is a difference. So operating expenses are the things that the actual service has to pay for to run the service, and cost of goods sold involves things like marketing overhead and legal help and all that kind of stuff. The point here is COGS and OpEx will be increased in margin or reduced in margin in the same percentage here, depending on the business, right? So if you're one business, you might decide that cost of goods sold is massive because there's a lot of overhead in marketing. And if you're another business, there's no COGS overhead for OpEx because you really believe in your user and your customer, right? So those will vary slightly. I think of it as COGS because that's the ultimate price.
I'm going to push back. I think it's a little more OpEx because it's going to be, if you can use your OpEx significantly, you can still have non-linear relations here.
I'll do the sword of Damocles here and I'll say you're wrong, but you're right. You're absolutely right. If you think of building services, you're thinking of OpEx. Like how much do I have to pay to burn the same processing power per unit for a customer? And you're not concerned with the overhead that the company charges the customer, right? If you're interested in COGS, you're thinking about what the customer has to pay, not what you have to charge. And they really vary depending on how much profit margin you want to drive for your business and things like this. So you're right, but that's a kind of an ancillary discussion. It really has to do with it.
It's a post presentation.
Yeah, exactly. Right. But I'd love to have it on the live stream too, because why not? A good squabble is like entertaining.
And if you just pay attention to OpEx, you know you're going to talk.
There you go. So I want to get to the demos here. So forgive me, because you're right about the distinction, right? There's a couple of things. The WebAssembly is already in Kubernetes. In particular, I'm going to call out Envoy network filters, which people may already know about. Okay. There's also KubeWarden, which does policy work, right? Enforces policy on deployment, right? If I'm not mistaken. And those things already exist and they use WebAssembly. There are other things, lots of things that use WebAssembly, but in Kubernetes, these are the ones that people sort of mostly know about. But there's several different ways you can integrate WebAssembly as a new process model in Kubernetes. And one we tried before is called Crustlet, which is a CNCF project. But we stopped at forward investment. Also, the other maintainers also did stop forward investment. And the reason is it worked. But what we were doing was we were modeling nodes, and we have to rebuild an entire node, which means that we have to actually make decisions about each specific kind of node. Once we get out on the edge, as I said, we're talking about constraints, connection, disconnection. We're talking about things like OSs and operating systems and various other things. And it turns out to remake the kubelet for each one of those is very, very difficult, right? It's a lot of resources that could be done, but we decided that containerd shims, our approach here, is the way to go. Now, there's another one out there that modified crun. And this is one uses the WasmEdge engine. So if you Google the crun WebAssembly, you'll find this one, WasmEdge as well. You'll find that one. I should say Bingle, but it just never works. That's an interesting approach as well, but it actually modifies the runtime inside the containerd. We found that the containerd shims allow us to be a lot more flexible, especially with operations. And there are others like WasmCloud, which I'm going to call out here. Brooke's in the corner over there. So if you have questions about WasmCloud, he's over there. I'll point you his direction. We're all going to be, like everybody here will be a Cloud Native Wasm Day in KubeCon in Detroit. So if you have larger questions, you want to see more, do deep dives, contact us. We'll be there. But like a lot of these approaches use CRDs, and there's kind of a reason. It's really hard to compete if you want to do networking. So WasmCloud does things like NATs and messaging and mesh, which is a kind of a form of mesh in a way. And if you want to do meshing and things like that, then Kubernetes starts getting really, really complex. And so CRDs are a way of sort of integrating into Kubernetes networking and doing your own thing, right? Like you can control how the operating model works with thing. But correct me if I'm wrong, Brooke, you can actually run WasmCloud sort of singly in Kubernetes just as a deployment, correct? If you have the runtime in.
Yeah, you can run it in Kubernetes, on Kubernetes.
Right. And you can definitely run it off of Kubernetes, right? Like this,
Yeah.
That's not an issue, right? But there are several other approaches like Phasm, which is actually a couple of years old. Some academics put together and tried to do it. And it's a little bit more complex looking at that model because a little bit earlier. So what I want to talk today about how we are doing it. We're doing it with containerd shims. And so this is all open source. Our expectation is that we're going to show K3Ds, which I love and which we talked about already, the integration that SUSE has with the Rancher desktop and so forth that they did. So we're going to use K3Ds. We're going to install K3D. We're going to bring up a cluster, apply deployment, and that's pretty much it. And so that's what we want you to do. So demo one, we're going to do the WASI spin function. And so this is Fermion. Now, nobody from Fermion made it here tonight. I begged them, but they didn't make it. So we can be mad, but they'll be there at KubeCon. So if you're interested in this, go visit them at KubeCon or go to fermion.com. You see the link on the top, which is spin fermion.dev/quickstart. And basically, this is running locally. So I want you to see the speed here. Okay, this is a single fire function. All right. And we used Hey. And we're talking at 2 microseconds. Is that right? Am I reading that right? 2 microseconds for the vast majority. That's not milliseconds. That's way down. Like if we optimize this, we could get in nanoseconds.
There are 0 kernel faults.
Yeah, there are what?
0 faults.
Yeah, this is basically returning a string. This is just hello world, okay? So this is also local. So I want you to understand the networking aspect has been removed. So we're really talking about just pure cold start. These are individual per request, you get a new module. So that means the request is multi-tenant, bounded by the sandbox of WebAssembly, which as we said is default deny, not default open. So each one of those requests is its own tenant potentially. This is how Cloudflare, Fastly, and others churn out their incredible speed and performance on cold start. So the only thing there is a listener here. Obviously, you have to have a process listening to handle the request and route it. In this case, it's WASM time, right? But it could be any runtime. So the second demo, and I can do all these, but I want to move on to the last demo that we've got, which is a little bit more complex and shows sort of what we're talking about here. This is WASI Slight. Slight is Spider Lightning. That's our project, which is very similar to Spin. We like the way that Spin does the model, right? The host model, and Slight does it similarly. But we've also got a suite of abstract interfaces. Remember the WASI components that we talked about, right? We've got abstract interfaces for key value stores like Mongo, right? And for things like blobs, for things like a core suite of services. And then we are working on implementation. So we have, for example, an S3 implementation. We have for an Azure blobs implementation. We have a MongoDB implementation of the key value functions. You can see that here, we're actually running in K3ds. Now I can run all these demos afterwards, so I don't want to take up too much time here because we're this is really an introductory sort of talk about why we do this, right? But we're actually writing to the file. We're doing file work here in K3ds, and we're pulling 7 microseconds. I'm sorry, we're wasting 5 microseconds doing file work, okay? But each one of those requests is unique to a tenant. There's no shared memory here. That's fantastic. You can see also for your question, if you can see, I don't know if you can see it, but the size request is 22 bytes. So again, we're not transferring a lot of information, but we are doing some work here. And that function is abstract. So we can change the implementation to point at Mongo, even if the Mongo is a container. Because it's containerd, we can run WebAssembly modules and containers side by side in the same cluster, which means you have a choice depending on which kind of OpEx or COGS you wish to optimize, right? So we're going to do another demo here. Now let's see if this one works. Are we visible? Okay. Now this demo is sort of what we're going to wrap up with because we've talked, there's a lot of information here. Now, this demo is built by a team at Microsoft that works with a whole bunch of customers. And they built this demo for Kubernetes with containers, right? And it's an order and receipt service, right? Like a standard kind of order service. And the people who built this stuff are here tonight. So you can ask questions if you want to talk about how painful it was to build it, because this stuff isn't easy yet, okay? And we'll talk about that. But, right? Don't call attention right away, right? You're going to start getting distracted. You can't do that, right? So let's start with this, okay? This person is laying out the application. There's an order service, a receipt service, and virtual customers. And they're going to show you some logs, right? And this stuff is all running through, what is it, Service Bus? Okay, Service Bus. But you didn't notice that she's the implementer, all right? So there's some calls here, and this is all container activity. So what Megan did, it took 13 seconds. Okay, fine. And we're going to go over here and we're going to refresh. And we're going to see a whole bunch of logs. And you can see that the MQ service bus should be thinking as an abstract MQ, right? Did you use the abstract interface and then configure the implementation?
The container-based version does use Dapper.
Right. So the container uses Dapper. And then what we're going to do, look at she's here, she gets deployment. If she mistypes something, we're going to ignore that because otherwise she's completely perfect.
We all do it.
Right? Yeah, exactly. No kidding. And she's going to go ahead and delete the receipt generation service, right? Which is a container. So after she does that, I want to sort of, I don't know if I can get that thing out of there. You can see it. I guess I got to get rid of yeah, there it goes. You can see that what she's going to do is actually deploy a different service, a slight service. This is a WebAssembly module in the same K3ds, right, cluster. And we're going to run get pods again, so it's up there. It comes up really, really fast. There's a reason, and we're going to see why. Because otherwise, these containers are pretty hefty. There's a lot of work. This is a real application. And so we ran it, and we're going to go over here and refresh. And we're going to see that, in fact, yeah, we did a lot of work, and we can keep refreshing and see all this stuff, right? No problem. But this mimics an actual real world app, okay? So we're going to go back here, we're going to see what's actually happening. All right. Now, first, awkward industries. I love this, right? Oh, dang. Did I do the, no. Oh, horrible. Let me find the place where we were. I actually clicked on the wrong place. All right. Look at this. Okay. That is the module, not the container image. That is the module that replaced the container image. Do you see the size? 2.94 megabytes. That's actually large for a module if you're thinking about the web, right? If you're thinking about browser. But think about containers. Watch. She's gonna go find that same module. You probably already have found it. She actually highlights the wrong module because I'm yelling at her in the background while she's doing this. So it's not really her fault. And so then she highlights the right container image. Now, oh, God bless it. Stop that. I gotta get back here. Gotta get back here. Okay, perfect. Right, it's the one below this. Right, that's my fault, not hers. Do you see the size? That's the container. Now, you're not always going to get a 100x reduction in size. Now, think about the reduction. You're thinking about network transport, you're thinking about registry storage, and you're thinking about local disk storage. Okay? But you're not going to think about 100x all the time, but you should be thinking 10 to 50x, depending on the workload. In this case, this is apples to oranges. That container is .NET, and that brings with it, that container is a pretty hefty container. That brings with it all the runtime stuff and the process support and the threading support, all that kind of stuff you don't have in WebAssembly. So the replacement is not .NET, although we can do it in .NET right now. Okay, experimentally, it's not supported yet, but we're working on it. The replacement is Rust. And the argument is not to tell you that Rust, because you can replace this right now with JavaScript. And guess what? You might be 4 megs, maybe 5. I'll give you 6, depending on your runtime. Okay. The point here is if you're in an environment where, for example, on the edge, where 210 megabyte containers per service that is architecture specific with a flaky network or low throughput network, right? Do you need to pump that container to space? Right? Or through a satellite phone? Look, I love Starlink in theory, but in practice, throughput is not massive. Okay. In those environments, you're not going to want to pump that through. So you should use that container when you're in hyperscale, right? And you should think about the module, because the gain, even for jumping to a language that's well supported now, C, C++, in some cases Go, even Python now runs there, .NET runs there. The .NET replacement for this might be on the order of 10 to 15 megabytes. I'm guessing, but I bet you $1 million I can come under 20. Okay. Even for interpreted languages like .NET, the win is fantastic, because now that same module can be deployed in a single node cluster with K3ds on a Raspberry Pi, and the developer doesn't do anything, and the pipeline does not rebuild the workload. That's the critical thing that we're talking about here. But don't make any mistake, this is not magic. It is a choice for engineering and business. Don't use WebAssembly when you can use containers. Don't use containers or WebAssembly when you need to use native. Make the right decision. But Kubernetes can go there if it doesn't always think containers, and that's the critical aspect. Let's go to the last bit. So please give these a try. Just get K3ds. There will be cluster APIs, right? Templates, so you can go ahead and spin up your cluster API where cluster wherever you want to do it. You just go ahead and do cluster create. That's the command, right? Straight out of the repository that I linked there. For Slite, which has the interfaces for application and service usage, including some that are AWS, some that are file systems, some that are Azure, we're going to go ahead and roll forward. We love contributions. If you want to compile things to Google, to DigitalOcean, to OVH, to Alibaba, just jump into the repo. We'd love to have it. But the developers will code to the abstract interface. Key value. blah, MQ, Event Hub kind of thing, Pubs Hub, right? These kinds of services they'll do. We're gonna, everybody, in fact, almost everybody working in this space will be at KubeCon in Detroit in another week and a half or whatever it is. Will be a Cloud Native WASM Day, which is the Monday. And also come around at KubeCon and have a deeper dive with any of us, Brooke, right? Anybody who's working in the WebAssembly space in Kubernetes or distributed application Cloud Native. We'd all love to talk to you, but I am particularly doing this same deep dive with a lot more information. I am co-presenting with Suse at the Azure Theater on Wednesday at KubeCon. I would love it if you'd show up. We can talk about all this stuff. We will talk about all this stuff now. I have dramatically exceeded my time slot. Thank you very much.
We started a little late. Thank you.
We started late. Great.
We did.
Thank you very much. And
Take a couple questions that we have.
yeah, absolutely.
Okay. Back.
So I understand you added something to the container to be shim to allow this to work. Just like the shared memory device, so it comes into this here.
Yeah, in fact, we're going to go here. I'm not going to go to Twitter because then I'd be live tweeting how great this was. And we're not going to do that. So I'm going to go to Twitter or not to Twitter. I don't know if I'm sharing anymore. So let me find the, okay, good. I'm going to show you the repo with the container and the shims, right? So that you can go and look, and then we'll talk, I'll talk through what we're doing. What's that? No. Okay, so for people who don't understand the integration point of Containerd, so Containerd is really a specification for an API. There is not really a Containerd runtime per se. It's actually an API that the kubelet talks to. Okay, I'm going to share. Let me share again. I'm going to share this screen because I want to show. Is that the screen I want to share? Let me try. Tell me if I'm showing a GitHub repo. Do I seem to be showing a GitHub repo? Okay, that is, you can see how I'm like complaining on Twitter. I'm doing WhatsApp. I sometimes check mail. I'm in the Bytecode Alliance.
You're in the address bar.
Yeah, exactly. I'm in the address. No, I'm sharing my personal information there. I want everybody to know. So I just wanted to call attention to the address, which is github.com Deus Labs, which is a Microsoft open source organization. All of our stuff is destined for foundations. So nothing that appears there will ever be, it will either go to a communal governance or we will archive it. So that's what that org is for, right? We don't do anything else. If it's in Azure or Microsoft, sometimes they go, if they're useful and people like them, they go to CNCF or they go to some other place, but often they don't. Deus Labs gives you a guarantee. Right? That's what we need to do there. So if you go there and go to Containerd WASM shims, you'll see two shims. We actually ship them together in some cases, right? The image that we actually install, that I showed you to install. And so you can look, this is a slight shim and this is a thin shim. What we're doing is, so Containerd is a API specification really. And so what we think of as vanilla Kubernetes, like if you install from upstream, for example, right? There's Containerd API and there's a shim inside, which is called runc. So there's actually a Containerd shim called runc. And what that does is actually turn around, take the message from the kubelet and says, okay, what am I supposed to spin up? I'm going to use runc to do it. Okay. So it's sort of like a hinge at that level. What this means is you got to bootstrap your cluster to drop the binary for the shim in. But let me show you what the difference is. This is what you have to do. Whoops, no, deployments K3D, no, deployments. So for any particular shim, these are two different shims. Here's spin by Fermion. I'll use spin. The only thing you have to do if the binary is on the image in the path, it's got to be in the path, Kubernetes got to find it, right? Is you need to tell Kubernetes there's a runtime class. And that runtime class is called, in this case, WASM spin. That's the runtime that spin is using, for example. Okay. Once you do that, you don't have to do it again. This is, in theory, a distribution would do this at boot time, right? And so, like, it's not a big deal there. The workload itself then just looks like this, right? And guess what's the only difference? Whoops, there it is. Now let me bump that up because people might not be able to see it. right? That is literally the only difference. You can even see the image there. What does that look like to you? To me, it should look like, now I'm walking away from the camera, I don't know if it matters. But to me, that looks like an OCI registry. And in fact, it is. That's in GCR. Okay. So you can store WebAssembly modules right now using OCI artifact support, which is pretty much all the major repositories and registries now support that for the most part. It was just the configuration stuff that was necessary for supporting OCI artifacts as a formal specification. I think was just merged. Was it just? Wasn't it just merged recently?
A while ago, but everyone besides Docker had.
Right, but so because like in this case, because in fact we built all this stuff talking with Docker and the whole thing. Docker is doing a sponsored keynote at Cloud Native WASM Day. So if you're at KubeCon, I'm expecting them to talk about how much they want to work with Docker. So one of the things we actually build some of our images with BuildX. So Docker's totally into this this approach to the process model in addition to containers. So even you might think of it as being different. Actually, Docker is looking at this the same way we are. Yeah. Go ahead. Yeah, Zach.
But I guess like.
Hold on, Zach. You get the mic.
All right, so I guess from my head, like.
Uh-oh.
What is a container? Like.
It's a process isolation mechanism.
Okay. So like in a pod, it's these aren't.
Huh?
Like these models and modules are kind of containers.
Yeah, the language is different. So like when you sit there and say process isolation mechanism, right? In containers, we know it's C groups and namespaces plus a bunch of other fancy crap that, you know, might twiddle some of the bits down below, seccomp, you know, all this kind of stuff, app armor rules and things like that. Okay. Collectively, I'm a big believer in Jesse Frizzell's constant, beautiful presentation forever. I will worship Jesse Frizzell as long as she walks on this earth. I will say there are no such thing as containers. There's a bunch of kernel configurations for a new process that prevent the process or non-root users from crossing that boundary. And the difference here is that the way the containers were implemented is they get to share the kernel, which is the thing that one of the things is kind of wonky. WebAssembly uses the sandbox language like Java does or like .NET does as like explaining the boundary that is created there. And so that's like the language is different, but functionally speaking, these are all containers. There's one other implication for the word container, and that is that it's an environment, right? And you can do distrolist and just drop a binary in. But you know how many people actually do that? Zero, with some modula of, I'm going to say this gentleman in the back, like sits there and thinks that's the greatest thing to do. In reality, most people, that's a compliment, by the way.
One time.
Okay, one time. That's totally fine. Because the real truth is most people are so busy that they can't spend time enough to learn that and master that workflow, right? It's a great idea, don't get me wrong, but it's really hard to do. So what happens in containers is you say from Ubuntu or from, you know, a Scratch or from like Alpine or whatever it is. And what you've just done is inherited an entire file system that came from somewhere else. And yet that entire file system really not related to your app. You're only going to use a little bit of it. And so the other implied difference between containers as a technology or as an approach to WebAssembly is that WebAssembly is really just the process code path, right? In a virtual machine, okay? A virtual machine, not even a physical one in any format like we think of VHDs. And nothing else. There is no file system. So when I'm talking about WASI and the, oh, did you have a question coming?
Finish first.
All right, fine, I'm done. So not quite done, but yeah, Scott can walk over there. So in modules, for example, with WASI, I actually just don't have to give you a file system. You don't have a file system if your service doesn't need it. If you're going to do image codec, if you're going to do some compression, like, do you really need a file system? If you're just going to do compression as fast as you can, no, you don't.
Yeah, you can do like the kernel bootstrap, right? You run one bar and then
Yeah, you just put it in memory and then you read it back out and you're done. So, I mean, like, that's what the gentleman suggests in the back for the people who might actually be listening and not sleeping right now. So the situation here is, as an engineer, you can optimize the feature set. And instead of being just an entire environment, it's actually just the code you wrote. And if you want something else as an environment, then you can go ahead and put in WASI libc, for
So
example.
I'm just saying, so as this matures, you do see Kubernetes as like that pod container model as being more generic.
So Kubernetes, so the question is, so as it matures, do I see Kubernetes still being, the pod concept being more generic? And the
you
answer,
see this like, you're hooking in right now at the data. Right? Like,
Yeah.
There was an old project that was trying to hook in at the Kubernetes.
yeah,
So you think this is, I mean.
Crustlet is not our way to go forward in the future. Although Crustlet and virtual kubelet, which is another thing, it's like Microsoft came up with 2 virtual kubelets, one in Go and one in Rust, and that's virtual kubelet. And they're both at CNCF. Okay, that's virtual kubelet and Crustlet, and so one's in Rust, one's in Go, and they're very useful for developers trying to prototype things and trying to get things running. ACI, Azure container instances based on virtual kubelet. Alibaba uses virtual kubelet and things like this, right? Okay, fine. But the kubelet is a node representation. And the real truth is, we as operators and we as developers, we don't care about, like the whole battle over serverless was to get rid of the damn server, right? So like, get rid of the node, just run the stuff, let Kubernetes handle it. And in fact, Kubernetes can. But so what you do with a container de-implementation is, instead of saying there's a special node that can run WebAssembly, which means you got to do taints and tolerations, which means now you have to have operator support for your application, right? With Container D, you can run pods, you can run pods with containers or WebAssembly. Doesn't matter. No taints and tolerations, just works. The only difference is the runtime class. That's it. And you can, in a Helm chart or in Customize or whatever, that's an if then, right there. So same chart, even. So that's why this is probably better. We model the process as a pod. Now, the interesting thing is, we actually did this first. People have to tell me to stop now because we can't stay here forever.
Do one more.
Oh, you're going to do one more over there? Okay, then we'll do it. So look at this one. This is walk. Now notice, I don't know if you noticed that this is archive, right? So this is an example of something we built. We tried to use. This is a CRI implementation for WebAssembly that we started before we started Crustlet. Now, here I'm going to call out Matt Butcher, a few other people at Deus Radu, a few other people that were originally at Deus, that were at Deus Labs at Microsoft when we acquired Deus, that did all this incredible, early work. Here's Thomas Taylor, Taylor Thomas. I'm reading it backwards. I always call Taylor Thomas, and it's my fault. Taylor was also part of the Deus crew, built this early on. This is Walk. It's a CRI implementation. Guess what we discovered? We discovered that CRI V1 is so hard-coded to containers and specific container things that it's not, we can't do it. Like, our original thought was to do this as a CRI. Now, the interesting thing is, what we discovered is that CRI doesn't work for that. And we had chatted with people at the CNCF, and they were like, you know what, we're probably going to have to model this. Like, this might be a good example for modeling a CRI V2. Now that's way off, because the community has to sit down and go, okay, how would that look really, kind of thing, But for example, we failed here with Walk first at CRI. Then we succeeded with Crustlet, but discovered the model wasn't right. And the container de-implementation is the sweet spot for operations, for developer experience, and for portability. So it's kind of amazing, that process. Yeah, let's go to the last one, and then we'll wrap up and get me out of here.
Apologies to the community for a dumb question.
All of them are good. This is a new space, right?
It's hard to describe my question, but I keep trying to gravitate towards like a familiar concept.
Sure.
As the various questions, every last and whatever was discussed about WebAssembly.
Yeah.
I keep thinking of firecracker.
Yeah.
Are they similar?
Yep.
Is it similar concepts? Like,
So the interesting, okay, so, yeah. Short version is Firecracker is not fast enough. So I can start in nanoseconds. Firecracker can't help me there, right? So and this is not a firecracker criticism, actually. So I'll tell you that in our internal work, so we have a project that will be coming out sometime in the next 3 to 6 months. I can't tell because we're going through security review and blah, 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 blah. But we actually jumped on firecracker as our possible solution for a slightly different problem. But with respect to WebAssembly, right? WebAssembly, the sweet spot, it's sort of like, okay, let me back up even more. The metaphor is, do you remember the first time you ran a container with something that you used to run a VM with?
Does it true count?
Does what? Yes.
That's a lot of work.
No, but like, for example, the one I always used to do is like somebody, Dustin, they built a Hollywood container, they did the Matrix. No, somebody else did the Matrix, but they did a Hollywood container. It did a bunch of TMUX windows and stuff, and it danced around and stuff. It was really, really cool. Now, I don't know how to do that. I'm not a TMUX expert, okay? I have beaten my head against TMUX a million times. I just decided to declare defeat and walk away. So that container was amazing because I could start 37 TMUX random processes in one window in like 3 seconds. I didn't know how to do that, right? And compared to VMs and reading a God blessed, that was really close. Reading a God blessed README that is 27,000 steps long and requires certain environment variables that I've never even heard of. And I'm in Zish and they're in Bash, and this is only POSIX Bash, and like, you know, all the stuff that can happen in Linux because you couldn't do anything, right? There is no way I could replicate that. And a container for a VM was like amazing. You could start it like that from anywhere. You could call the container from like, you know, Timbuktu over a cell phone, which is 3G or maybe even 2G. You could do a modem dial up and it would work. Well, the containers were amazing, right? This is another step down that path. It is not the same as a container. It doesn't do the things a container lets you do. So don't think it's a replacement. Okay. But what it does do, if you treat it with engineering respect, is allow you to start in 4, 5, 6 nanoseconds. You can't do that with a container infrastructure at all in any way. You can't do that with a VM, even Firecracker. Now, that said, we tested Firecracker out a ton because it would have been great to use that. Okay. It does work. And if you do that and run that in like a Kubernetes cluster, like we tested KubeVirt, like why not KubeVirt, right? 6 seconds boot time. Okay, Firecracker was like, what was it, 2 seconds? I think, really fast, right? We're talking nanoseconds for WebAssembly. Not if you do everything, not if you treat it like a container. You treat it like a fast starting function and you optimize your deployment and your code for that, you can be under a millisecond. And you get the sandbox default protection and so forth. By the way, the sandbox hasn't yet been broken. So there are security problems with WebAssembly, just like any other runtime, okay? And it's not that WebAssembly, but the sandbox is mathematically solid. So the sandbox hasn't been broken, but runtime bugs have appeared that allow you to escape the sandbox. That's not a sandbox. So the interesting thing is, we think is as we get practice with this, as we go forward, we're actually going to be able to get to the point where something like a WebAssembly VM or even a WebAssembly container, although I don't believe in that, would be possible in a way that is as strong as things like virtual machine boundaries. Yeah, Firecracker is great. I love it. It just doesn't suit the sort of optimization feature here. Steve, you're going to say something, but I got to get out of here or Ariel's going to kill me.
Wait, I assume probably also saw lower research utilization on WASM versus even Firecracker.
I didn't hear a word you said. Try again.
I assume you saw even lower resource utilization on WASM versus Firecracker.
Yes. So
Firecracker's a little more research.
yeah, but there's reasons. Firecracker is giving protection at a very, very different level, right? So it's doing a lot more work. So the resource consumption for Firecracker is substantially larger. These are engineering choices, right? Don't think it's better or worse. Think of what is your engineering choice. Ariel, I apologize. Thank you very much for all of your patience. I hope it was interesting.
Fascinating conversation. We have another